Hello guys, welcome back to Ideal Bibliotheca. As planned, as discussed, and as we were going, we are to continue in this video with the second chapter of Science NCERT Class 9, and hopefully, likewise, after this video, you would not have to refer anywhere else, not even the book, but we are done with it. So let's begin.
We had one whole chapter over matter where we studied about what is matter exactly, and here we have is matter around us pure. Here we know about what all things we have. We have what is a mixture, types of mixtures, and what is a solution. They talk about alloys, they are talking about the concentration of a solution, their properties, and what are their types, like colloidal solution and other things, and properties of those colloidal solution, then separating the mixture and everything, how can we separate other things and everything. It's all of a big task compiled in a very small chapter, and then they say that all the NCERTs are important. Trust me guys, NCERTs is boring. I don't know if you find it, do comment it down and let's link together with yes, it's not an interesting part. Then we have physical and chemical changes, what are the types of pure substances, elements, compounds, and everything. So basically, it's everything about substances, the summary, and then the exercises. So let's quickly complete this. I am trying my best to not keep it even for the half an hour thing like we had it for the first chapter, and we complete it sooner than that. Let's just try, let's not promise. So what is a mixture? The first thing that they're talking of is what is a mixture? Mixtures are constituted by more than one kind of pure form of matter known as a substance. So what is a substance? Pure form of matter, and a substance cannot be separated from other kinds of matters. So this is what is a mixture all about. Then we have types of mixtures. In the types of mixtures, we are just given it via the activity. What are the different types they have taken out. But here now we are learning about the solution. So what is a solution? A solution in the first type is the homogeneous mixture of two or more substances, but this is homogeneous. So just remember this. And in that we also have a small portion called alloys. What are alloys? Alloys are a mixture of two or more metals or a metal and a non-metal cannot be separated into the components by physical methods, and that is called alloy.
Then we have a solution has a solvent and a solute as its component. The component of the solution that dissolves the other component in it in larger amount is called the solvent, and the component of the solution that is dissolved in the solvent is called the solute. So what they are actually talking about is, like, suppose we have water and we have sugar in it. So the component in it, the component present in larger amount, that is the water, is called the solvent, and the component of the solution that is dissolved in the solvent is called the solute, that is sugar, is called the solute. So this is it what they are talking about. And then what we come to is the when the small portion from the topic concentration of a solution, where they are writing that when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution, and the amount of solute present in the saturated solution at this temperature is called the solubility. Also, an unsaturated solution portion is given, where they are saying that if the amount of a solute contained in a solution is less than the saturation level, again that's the unsaturated solution. Also, one small formula: concentration of solution is equal to amount of solute or amount of solution or amount of solvent. Thus, the ways of expressing the concentration of solution we will learn in two methods, which is given here. Mass by mass percentage of a solution is mass of solute by mass of solution into 100, and mass by volume percentage of a solution is mass of solute by volume of solution into 100. And then there's a small sum here, an example that you can think of, that you can know, and you will understand what all it is. But that sum is not important to us, because at the end UPSC wouldn't ask you in that CSAT, right? So what is a suspension? Again, solution was one thing, suspension is the another mixture that was homogeneous. This is heterogeneous mixture, where solute particles do not dissolve but remain suspended throughout the bulk of the medium. So here again we have a lot of parts, but one thing that we have here is what is a colloidal solution. What it is, a mixture obtained by the activity that is given there, that is called a colloid or a colloidal solution. What happens in this is that the particles here are uniformly spread throughout the solution, and that is what we call it as colloidal solution. And because of the small size of these particles, we cannot see them with naked eye, but these particles can easily scatter in the beam of light as given in the diagram. Then we have that there's a small effect that they have talked about, Tyndall effect, that's called, and can be observed when sunlight passes through the canopy of a dense forest. Mist contains droplets of water which act as particles of colloidals dispersed in air that we are talking of. Again, properties of a colloid that they are asking is heterogeneous nature again. So this is one part: size of particles too small. Colloids are big enough to scatter a beam of light, and they do not settle down when left undisturbed. So they do not settle there also. Then we have, they cannot be separated from the mixture by process of filtration, but a special technique is required, which is called centrifugation, which is used to separate these particles. And there's also one small portion here, that the solute like component of the dispersed particles in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersing medium. Then we have small questions round here. I hope we did not miss out on any of the questions. Oh, we missed out on 2 questions, guys, here. The first one is, what is meant by a substance, that they are asking. Again, pure single form of matter, that we learned, that is there. And list the points of differences between homogeneous and heterogeneous mixture. The first that you can say is, here in the homogeneous the particles are uniformly mixed, and in the heterogeneous you can say that they are completely mixed and they can be distinguished with bare eyes or under a microscope. Then again, they have a uniform composition, both are equal, and heterogeneous, they might just have an irregular composition here in the heterogeneous part. Again, they have no apparent boundaries of division, and in heterogeneous there are boundaries of division which you will find like water and oil that we see, but that's not an example here. I'm just giving you for the sake of understanding what is the boundaries of division that they're talking of. Now let's jump to the next question that we actually fell on for the first time. Here they are asking, differentiate between homogeneous and heterogeneous mixtures with example. Okay, this is what we did here again, but this time with examples. So example for homogeneous mixture you can take as rainwater or vinegar, because see, rainwater also has a lot of things involved in it, but then when you take rainwater or you keep it in a bucket or something, you might just not find the differences, the boundaries in it, and they are all equal in numbers. Heterogeneous, you can talk of seawater, blood, etc. for the heterogeneous example. Again, how are sol, solution and suspension different from each other? That you will see, you can base them on a lot of things like the type of mixture, because sol as a type is the heterogeneous part, solution is homogeneous, and suspension is again heterogeneous. So in that ways, the size of particles, they might differ. In the Tyndall effect, the sol is the exhibited part, solution do not exhibit, and suspension might or might not exhibit. Again, their appearance you can talk of, their visibility you can talk of, their diffusion you can talk of, their stability, that sol is pretty stable, solution is highly stable, but suspension is clearly unstable. And then you can talk about this settling, that yes, so sol gets settled in centrifugation, solution does not settle at all, and suspension settle on their own. So they all have 3 different characteristics all the while, and examples you can give, and accordingly you can differentiate them very nicely. Now the third question is, to make a saturated solution, 36 gram of sodium chloride is dissolved in 100 gram of water at 293 K. Find its concentration at this temperature. So what you have to do is, again, you have to find out the mass of the solute, that is NaCl, which is given here 36 gram. Mass of solvent is given to you 100 grams, and mass of solution would be again what? Mass of solution would be this plus this, right? So you get this as 136 gram. Again, now concentrations formula was what? Mass of solute by mass of solution into 100. So what would be that? Mass of solution is this plus this, and mass of solute is just 36 gram. So 36 gram by 136, 36 by 136 into 100. Into 100 is this whole, like this is in bracket. So you get something in percent you might be getting, and that percent is your answer, the concentration of the solution. Next, when we move on to see common examples of colloid are given here, what all can be the examples, the types, and the examples are all given here. You can go through them to just have a glimpse of what all are the examples. Separating the components of a mixture that they're talking of, and there are small activities, but then there's one small portion from here that you can just know, that we can separate the volatile component from its non-volatile solute by the method of evaporation. This is one small thing that I felt might be important. And another is that sometimes the solid particles in a liquid are very small and pass through a filter paper. For such particles, the filtration technique cannot be used for separation, right? So such mixtures are separated by centrifugation then, and the principle is that the denser particles are forced to the bottom and the lighter particles stay at top when spun rapidly, and accordingly they get separated. Then we have, how can we separate a mixture of 2 immiscible liquids? And one small thing that is there is that these liquids separate out in layers depending on their densities, and accordingly we can differentiate and separate them. How can we separate a mixture of salt and ammonium chloride? Again, this experiment is given here, and to here we can know that yes, they contain a sublimable volatile component from a non-sublimable impurity. Sublimation is used to separate a mixture of salt and ammonium chloride. Is the dye in black ink a single color? And again, the ink that we use has water as the solvent and the dye is soluble in it, and as the water rises on the filter paper, it takes with it the dye particles. Usually a dye is a mixture of two or more colors. The colored component that is more soluble in water rises faster and the color gets separated. So the process of separation of components of a mixture is known as chromatography, which is the technique used for separation of colors was for the first time. Then another is how can we separate a mixture of two miscible liquids. So immiscible was sublimation that we had here. Immiscible was the separating out of layers, and separation of a mixture of salt and ammonium chloride was sublimation. And the normal miscible liquids can be separated by the process of distillation, where the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points is seen. Then we have how can we obtain different gases from air, and then the small explanation is given here that you can go through. Again, the question asks is how can we obtain pure copper sulfate from an impure sample? That is through the process of crystallization. What is crystallization? It separates a pure solid in the form of its crystals from a solution. Applications can also be important, guys. See, purification of salt that we get from seawater is done through crystallization. Separation of crystals of alum from impure samples is again crystallization. Accordingly, we had other applications around here that you can go through. That see the chromatography, see to separate colors in a dye, pigments from natural colors, drugs from bloods. So these all in real life chromatography is used for those. Then we come to the questions again. How will you separate a mixture containing kerosene and petrol? Difference in their boiling points, which is more than 25 Tc, which are miscible with each other. See, the question that they're asking is how will you separate a mixture containing kerosene and petrol? See, we saw the miscible liquid can be separated by distillation, so you have to mention about the distillation, and the whole concept established on the volatility property of substances, and the steps you can mention of the steps from the activity that was there above distillation. You can go through that and just mention it here. Your answer would be complete if you really want to answer this, because steps I don't think that would be important any day. Anyway, next is name the technique to separate butter from curd, salt from seawater, and camphor from salt. Camphor, if you don't know, or you might just have forgotten like me, I did not right now, but yeah, sometimes I do. Camphor in Hindi is called kapoor that we use while we worship God and everything. In the diya that we use, that's camphor. So camphor from salt, how can that be differentiated? So butter from curd, you can do it through the process of centrifugation. Why? Because this is done on the principle of density, and again butter and curd have different densities. Salt from seawater, again simple evaporation technique. Why? Because the distillation causes water to evaporate and then solid is left behind. And camphor from salt can be done by sublimation. Why? Because camphor does not undergo a liquid phase and salt would, so it would ultimately differentiate. Again, what type of mixtures are separated by the technique of crystallization? This again we went through this, that the technique of crystallization is used to separate solids from a liquid solution. How? Because they precipitate, and then after precipitating they achieve a crystal form which exhibits extremely high levels of purity, and thus the substances are separated. Then we have physical and chemical changes that they're asking of. Nothing to know something apart from everything that we already know, because these are something that we might have gone through in our childhood also, and we've gone through all of these, so this is not something that important. Classify the following as chemical or physical changes. See, cutting the trees is again a physical change, because it changes because of that. Melting of butter in a pan, again physical change. Rusting of almirah is a chemical change. Boiling of water to form steam is physical change. Passing of electric current through water and water breaking into hydrogen and oxygen gases is chemical change. Dissolving common salt in water is physical change. Making a fruit salad with raw fruits is physical change, and burning of paper and wood is chemical change. Now, try segregating the things around you as pure substances or mixtures. So you can just look at what. Maybe water, salt, iron, or diamond, if you can look at, and pure substances, that could be them. Mixture, you can think of steel in your kitchen, or soil in plants, or food that you eat. You can think of all those as mixtures, and air that we breathe, definitely. So yeah. Then we have what are the types of pure substances. In that, the first part is elements. Second, pure substances, compounds. And yeah, mixtures and compounds again have a difference. So here we'll see that, and accordingly the chapter will end. Okay, so let's quickly go through this. Elements, the first thing that we have, a small portion again, can be divided into two metals, non-metals, and metalloids, 3. So again, the properties of metals are here, the properties of non-metals are here, and the properties of metalloids would be somewhere. It's not here. So non-metals and metals, the properties are here. So guys, just go through them. Compound is a substance composed of 2 or more elements chemically combined with one another in a fixed proportion, and again there's an activity here, so you can go through that if you want. Mixtures and compounds, the difference, what are their elements or compounds just mix together to form a mixture, and no new compound is formed. Elements react to form new compounds. Mixture has a variable composition. Each new substance is always fixed. Mixture shows the properties of the constituent substances. The new substance has totally different properties. Constituents can be separated fairly easily by physical methods. The constituents can be separated only by chemical or electrochemical reactions. So this was it with this chapter, guys. This was big, tough. And but still we had to cover it, so we couldn't help it, right? So now we come back to again exercises. Which separation techniques will you apply for the separation of the following? Sodium chloride from its solution in water. See, very easy because evaporation would be perfect here. Then we have ammonium chloride from a mixture containing sodium chloride and ammonium chloride. I think we can go for sublimation because this was there already mentioned in the chapter, so nothing of a tough thing. Small pieces of metal in the engine oil of a car, they can be just filtered, and accordingly things would just come out from it. And then we have different pigments from an extract of flower petals. This you can go through via chromatography. It's given in the chapter. Butter from curd, we've already discussed. You can do it via centrifugation. Oil from water, that can be done by I think oil and water would be immiscible liquids, right? And for that immiscible liquids, we just had it that via funnel or via something, we can just pass them out and they'll just separate. Tea leaves from trees, that would be manually separated, the normal filtration thing that you can have. Iron pins from sand, I think that can be done because iron is a magnet thing, so I think magnets might just help here. And wheat grains from husk can be done by I think this isn't mentioned in this chapter, but I remember when we were young, there was a small portion called winnowing that was given, and that was particularly used for this husk and the wheat part. So I think that winnowing technique would be used here. Guys, if you know about what winnowing is, do comment it down. I know about it, but I really want to see if you know about it. And if you do not know about it, you can just Google this word. You will get what I am trying to mean here. Then we have fine mud particles suspended in water. This again is very easy because what you can just do is sedimentation, decantation. Sand and water has been always easy. So yeah, you can do it that way. Next we have write the steps you would use for making tea. Use the words solution, solvent, solute, dissolve, soluble, insoluble, filtrate, and residue. So guys, the next time when you make tea, you've got a task with you. And I don't know whether we should be going through this or not, but I'll just go through very easy part. See, when we add a cup of milk, you call milk the solvent. When tea is added and that tea powder is boiling in the milk, that you can call as solute. So your solvent is just let me erase this first so that it's easy to know what all we have found. So your solvent could be the milk, your the solute could be tea powder which is then boiling in the milk, and then solute, that is the tea powder, remains insoluble, so it's still boiling. And when you add sugar to the boiling solution, so what is solution? The milk and the tea powder already remaining there, and accordingly, so when you add sugar, sugar is a solute. Again, sugar is a solute and it is soluble in the solvent. Solvent is milk, so sugar is soluble in the solvent. So that is done. After continuous stirring, you will reach the saturation. Okay, saturation is not mentioned here, so we can just avoid it. And then you can talk about that once the tea is made, like boiled enough, take the solution off the heat, filter or strain it, like filtrate it and everything. And the insoluble tea powder remains as a residue. Why? Because they will be left out, they will not be a part of your tea. And solute and the solvent strained through the filter medium, which is collected as the filtrate again. So this is it. And dissolve you can use when you are writing of the sugar getting dissolved in the milk and everything like that. So the third question is, Pragya tested the solubility of 3 different substances at different temperatures and collected the data as given below. This I'm not doing, guys. This is typically wrong. This is something you shouldn't be asking people. But yeah, we'll have to complete it. We can't help it, right? So the first question is, what mass of a potassium nitrate would be needed to produce a saturated solution of potassium nitrate in 50 grams of water at 313 K? Again, see, mass of nitrate is given in 100 gram of water at 313 K, which is 62 grams, because it is already given here, and accordingly you can just figure it out. So mass of potassium nitrate to produce a saturated, see, when 100 grams of water was required, 100 grams of water was given and temperature was 313 K, it was 62 grams, right? So when 50 grams is there and temperature is 313 K, apply unitary method and you will get the answer. And thus the second question is, Pragya makes a saturated solution of potassium chloride in water at 353 K and leaves the solution to cool at room temperature. What would she observe as the solution cools? Okay, when the question is this, the simple answer is that she'll again observe crystals of potassium, because after the solubility at low temperature is done, it will surpass and accordingly a crystal would be left out. Find the solubility of each salt at 293 K. Which salt has the highest solubility at this temperature? When we see potassium nitrate, see, solubility of each salt at 293 K, right? So when we have potassium nitrate, it is what? 32 by 100. When we have sodium chloride, it is again 36. Potassium chloride, it is 35 given. And the solubility of ammonium chloride, it is given 37. So all of these would be at 293 K. Then what is the effect of change of temperature on the solubility of salt? Again, what would happen is, because the temperature is the salt is depending on the temperature, so it will again increase with an increase in temperature. So when the salt would arrive at a saturation point, a propensity to dissolve more salt to an increase in the temperature of the solution would be given, so that the propensity is there, is the effect of change on the temperature which is given. Explain the following, giving examples: saturated solution, pure substance, colloid, suspension, all given in the book. Just go through them, and I mean all given in the chapter that we came across. So all given here, you can go through them. Classify each of the following as a homogeneous or heterogeneous mixture. Let's go through this. This might just be interesting. Soda water. The first thing is soda water. Soda water is what? Homogeneous. Wood is what? Heterogeneous. Air is again homogeneous. Soil is heterogeneous. Vinegar homogeneous. Filtered tea homogeneous. And then we have How would you confirm that a colorless liquid given to you is pure water? Because a colorless liquid is pure because if it boils at 100 degrees Celsius, it is said to be pure. But if there is an increase or a decrease in the boiling point, water has added impurities, hence not pure. Hence, a colorless liquid is pure by setting it to boil. Which of the following materials fall in the category of a pure substance? I think you can call out ice, you can call out iron, you can call out hydrochloric acid, you can call out calcium oxide, and you can call out mercury for the pure substances. Identify the solution from the mixtures given below. The first is soil, seawater, air, coal, soda, water, and we have to find out the mixture. So that's seawater, that's air, and that's soda water. Which of the following will show Tyndall effect? That is, Tyndall effect can be exhibited only by milk and starch solution. So ultimately, the starch solution and milk are the answers. Then we have the next is classify the following into elements, compounds, and mixtures. When you look at them, you would find that sodium is what? Sodium is an element, soil is a mixture, sugar solution is a mixture again, silver is an element, calcium carbonate is compound, tin is what? An element, silicon is what? An element. Then we have coal is again what? Coal is mixture, air is I think mixture, soap is mixture, methane is compound, carbon dioxide is why don't you mention carbon dioxide? Okay, just kidding. Carbon dioxide is compound, and blood is again a mixture that we've already seen. And which of the following are chemical changes? I think growth of plant is a chemical change, rusting of iron is a chemical change, cooking or mixing of iron filings in sand, no. Cooking of food is a mixture, the chemical change. Digestion of food is again a chemical change. Freezing of water, no. And burning of a candle is a chemical change. And that is how we end the chapter. Oh god, NCERTs could be this difficult. Telling you guys, polity, history. I think NCERTs of all other subjects is also gonna be as tough as this, but we've covered it, and thankfully you can go through them. So this was it with chapter 2, and let's quickly start with chapter 3.
So this was it with today's video, guys. Next we meet on Science NCERT chapter 3, discussing that and all the back questions and everything. Until then, keep watching this, keep watching other videos so that we keep revising and everything. If you like it, like it. If you do not, unlike it. And if you like it, do let me know in the comment section what about in everything that you've liked about it. And if you haven't subscribed, do subscribe it so that we are ready with the next notifications very soon. Thank you.